This is Dr. Frederick responding to this question from Jorge or George about whether or not you can use Excel to perform the Tukey Kramer procedure in a randomized block design. Now, first of all, when you post your question, Jorge, put Module 2, Question 3. You do have Question 3 down here, but just in the title, put Module 2, Question 3, and that would be very helpful. Here is the question here. We have 6 experts rating 4 brands of coffee. So this can be a randomized block design. 6 experts, 4 conditions. And, use these elements over here to help you think through a problem. We're going to view an example of this problem. And first thing we're going to see is this is how we're going to set up the problem. I have the problem set up here in Excel. I just type it in like this. Alright, and then we're looking for an output summary table like this. I'm just going to go to data. Now, just let me show you real quickly what you may not know is you have to go to options, you have to go to add-ins, and then you have a very nice tool pack right here in Excel. We're going to go down Manage Excel Add-ins. Okay. Well, I thought I would get that. Let me just do it again. Well, I already have it added in. That's the problem. So you're looking to add in your data analysis tool pack, which I already have in here. And so I picked that, and I'm going to do the ANOVA 2-factor without replication. I click OK, and I've already selected up here what I want. I tell it that I have labels so that it can deal with these non-numerical data here. And then I click OK, which I've already done. And over here we see the output. Now the output doesn't look exactly like this, but here we just match everything up. The source of error among groups is what it calls columns. Remember, our columns were our 4 groups. So the error among groups is here with 3 degrees of freedom, 4 minus 1. And we see we got the same value for our sum of squares is 130.125. The mean squares is 43.38. Now for our experts, we have 6 rows. The degrees of freedom is going to be 5. And here's our same thing over here, 5 among blocks. 58.21, 58.21. Mean square of 11.64. And then we're going to get our F value down here of 16.01. And 4.3 for our F value on blocking. And we're interested in whether that's a significant F or not. Now we go down here, this problem just continues. Gets 3.29. It's going to compare that to an F critical of 16.01. And I'm sorry, I said it wrong. The 16.01 is greater than the F critical of 3.29. We're going to reject the null hypothesis that blocking was not important. Continue with this to the question that you have, is whether we can do this Tukey's just in Excel. And I'm sure we can. Let's go back and see how we're going to do this. First, we're going to want us to remember this table because we're going to get our mean square out of here. So we go back to sheet 1. Now look, we're just going to get our averages for each coffee brand. And then we're going to have 6 comparisons between them to look at whether, which coffees are different than others. Obviously, coffee A and coffee C are the same. But you see I have the same means there. You can do this right in Excel very easily with a little command. And then we're going to compare the means. And if you look up here, that's what I actually typed in. It's just to get the absolute value. And let me just show you how you do that. You do equals absolute value. And then just touch what you want to do. So I want to take that, I want to subtract this, right? In parentheses, hit enter, and you get your value. You just have to do that by hand. Let me do the last one here. Equals absolute value of average C minus average 8. In parentheses, hit enter. Okay, so now that's what they do in this example, just the same thing. They show you the absolute values of the differences there. All you want to do is now compare that to get some critical range value here using your Q alpha, and you have to figure out what the degrees of freedom for Q alpha are. You can go to the web and get this, and so here we have 4 treatments, and what are our degrees of freedom? It's R minus 1, which is what? 6 minus 1 is 5, and C minus 1 is 3. So 4 and 15, and we get 4.08 down here. And that's what they got. We then use this value. We're going to go back and look at our mean square. Our mean square is 11.64. I'm sorry. I'm looking on the wrong line. 2.71 for the error. Okay. So they put mean square error in the numerator, R 6 experts, 6 blocks, 6 into that, then multiply it out, and then you get a range of 2.72. And now we're just going to go back and look at our means and say which differences were greater than 2.7, and that's where we have significance. So you can do the whole thing in Excel. You don't even need PHStat to do this. I hope that question is helpful. Please let me know if it is, or if it isn't.